Alright, we are looking at power rule day 2. We're going to look at what happens when we introduce our negative exponent powers. So remember, the power rule is when we take a power to a power. Those powers end up multiplying. It is kind of like the distributive property. The thing is, no addition or subtraction symbols allowed. So for instance, I can have x to the third to the fourth. Our power rule says that this 4 multiplies that 3, and I get x to the 12th. I can even have x squared y to the 5th to the third power. The 3 would go with the 2, would go with the 5. That looks a lot like the distributive property. It's true. We get x to the 6th, y to the 15th. But if we had x squared plus y to the 5th to the third, almost identical to this one, the power rule doesn't work. All because of this plus sign right there. So as long as you don't have any plus or minus signs, down with the big numbers, it still works. So for instance, let's take a look at what it looks like with a negative exponent power. Just because it's negative doesn't change anything about our power rule. There's a 1 power on the 2, there's a 1 power on the 4. This negative 4 multiplies both of them. This becomes 2 to the negative 4th power, and this becomes x to the negative 4th power. This negative, you notice how it's tiny, itty bitty negative, does not become negative 2 to the 4th. No. No. No, 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 no. This negative 4 power, because it's a negative exponent power, means it has to flip to the other side of the fraction. Right now it's on the top, so this 2 to the negative 4th moves to the bottom. Becomes positive 2 to the 4th. Same with the x. Becomes positive on the bottom. Since there's nothing left on the top to hold the place, we put a 1 placeholder. We then take 2 to the 4th, and we get 16. This is your final answer. At no point does this become negative 16, and this does not become negative x to the 4th, with the 2 negatives canceling out and giving us this. No. Negative exponents cause them to move within the fraction. Top to bottom, bottom to top. This negative does not all of a sudden grow in size and get to fit onto the big number. It's a little negative, cannot affect the big number like a big negative. Let's try one where there are no negative exponents just to keep practicing. This 4 multiplies the 3, multiplies this 3. It also has to multiply the exponent power that's not currently listed on this 4. That gives us 4 to the 4th, x to the 12th, y to the 12th. 4 to the 4th power is 256. X to the 12th, y to the 12th. Since nothing has the same base, and we can't just regularly multiply these two, that is our simplified answer. Okay. Another one with some negatives. The negative 3 is going to multiply the negative 2. It's going to multiply the positive 2. It's also going to multiply the power over here on the 4. That gives us 4 to the negative 3rd. gives us m to the negative sixth, but it gives us n to the positive sixth. They're all on the top of the fraction right now. We know they're all on the top of the fraction because they all started on the top of the fraction over here. My negative exponents are going to move to the bottom of the fraction. So n to the sixth gets to chill on the top. I have 4 to the third and m to the sixth. We're going to simplify the 4 to the third power. That's 64. M to the sixth. Because none of them are the same base. This is a regular number, and it doesn't do anything with the 1. And n and m are not the same letter, so we can't use any other rule. We're done right here. We'll skip that one because I want to look at one that's already in our fraction form here. This 4 goes to all of the exponent powers, even the ones on the bottom. So we now have 2 to the 4th, r to the 8th, all over r to the 16th. I'm going to simplify 2 to the 4th. That gives us 16. R to the 8th, r to the 16th. We do have the same letter on top and bottom. Both of these are r. So this is going to require us to use our quotient rule. When you have two like bases being divided, the powers subtract, top minus the bottom. So I have 16. We're going to take the 8 and we're going to subtract the 16 from the bottom. That gives us r negative 8. Can't have a negative exponent. Looks too much like the same problem. 16, we move the r to the bottom to be r to the 8th on the bottom. If we were to look at the problem here, where do I have more r's to start? I have more on the bottom. How many more than the top? 8 more, so these 8 cancel out with 8 of these, and that's how we get our final answer of r to the 8th. Let's try a similar one with a few negatives thrown in there. This negative 1 is going to go to the 2. It's going to go for this first p. It's going to go for this p, and it's also going to go to this 2. Giving us 2 to the negative first power, p to the negative fourth power, all over 2 to the negative first power, and p to the third power. A lot of negative exponents. So every negative exponent has to switch to the different side. So this negative 2 moves up, this negative 2 moves down, and this p moves down. So we get 2 to the first power, all over 2 to the first power, p to the third, p to the fourth. Well, what's cool is this 2 and that 2 cancel out, leaving us just a 1 on top. And then both of these p's are multiplying, requiring us to use our product rule. I have 3, there are 4. We add those together and we get 7 on the bottom. With our last example here, got a few more of our negatives that we're going to throw in here. I want this one to be the last one. Yeah, we're going to make this one the last one here. With our negative 4, this negative 4 only applies to anything that's inside the current parentheses. So this negative 4 just goes to these two terms, doesn't actually affect this k at all. I know that this k on the top will have to move, but for now I'm going to get everything else more simplified. Like this. The 2 switches, the k switches, giving us 2 to the 4th on top, and then k to the 8th times k to the 2nd. 2 to the 4th is 16, and all multiplied out. Then this is the product rule, because we have 2 terms with the same base multiplying. 8 plus 2 gives us k to the 10th. That's our final answer.